Obtain the expression for magnetic energy stored in a solenoid in terms of magnetic field B, area A, length L of the solenoid. How does this magnetic energy compare with the electrostatic energy stored in the capacitor? Start from energy in the inductor. Energy equal to half Li square. Energy stored in the case of inductor is half Li square. Now, what is the coefficient of self-inductance for long solenoid? L equal to mu 0 N square Al. Magnetic field along the axis of the solenoid B equal to mu 0 N. So we'll get I equal to V by mu 0 into N. Now we'll substitute energy in the solenoid is half L value mu 0 N square Al into I value B by mu 0 N whole square. If you simplify, you are getting half mu 0 N square Al into B square by mu 0 N square. Half into B square, mu 0 get cancelled, N square into Al. So after simplification, you are getting this magnetic field. Energy, this is only energy, right? Okay, energy density. What is energy density? Energy per unit volume. We got the total energy. You can make out here, AL is volume. I am dividing by volume. AL will get cancelled. What is remaining? B square divided by 2 mu 0. This is UB, energy stored per unit volume is given by this expression. How does this magnetic energy compare with the electric energy? Now, electric energy equal to, similarly, the electric energy equal to energy density, electric energy per unit volume, that is equal to half epsilon naught square. This we have already derived in first chapter, right? And electric field, while deriving expression for capacitor, energy stored in the capacitor half C square. Energy per unit volume is half epsilon naught square. So we can compare this one. This is energy in terms of magnetic. Magnetic energy per unit volume is B square by 2 mu naught. Electric energy per unit volume is half epsilon naught into A square.